When it's going to come down, and I hit that 75. Then what happens? It splits. So I'm going to make a little node there. I go this way and this way. And if I'm driving, it's a right turn. If I get on the right side, I've got 1800. And if I were to go left, I have 1250, and then 750, and then 485. Ohms, ohms, ohms. Now they rejoin, don't they? And my last resistor, which everything passes through again, is 200 ohms. Okay, so just looking at this, I know that the 200 ohm and the 75 ohm are going to equal my total current, right? Everything passes through the 75, everything passes through the 200. So I'm going to have a total current, which is going to match R1's current and R6's current. These two paths, it splits. So this path and that path combined will add up to my total current. Just like the river. So I'm not gaining, I'm not losing. I've got a certain amount of current here. When it comes back together, I've got the same, but I'm only taking two paths. So the two paths combined will add up to my total. So I'm going to write down the values that we're given to me. Down here, I've got 12 volts. And I've got 75, 1800, 1250, 750, 485, and 200. The first thing I want is my total resistance. So I'm going to start my next redraw. I'm going to do 12 volts, 75 ohms, a question mark, 200 ohms. And there's my demo. All right, so all I need to do is figure out right now, next, is what my total resistance in the middle is. 43. Are you already there? Yeah. So I'm adding 1250, 750, and 480. What's my total resistance of these guys? 2485. 2485. So now I do 1800 x over 1 plus 2485 x over 1. 1043.82. Everyone with me? Everyone with me so far? Don't hesitate. Don't be afraid to say if you're not, because I'm pretty sure that there's some people that aren't with us so far. Forget about this top part, and forget about the bottom half while we're doing this middle section. These three resistors we treat as one resistor because they're series to each other. And they were 2485. So now we can pretend that is one resistor of 2485 ohms. And then it's parallel to the 1800 ohm. So anytime we have resistance in parallel, we do that x over 1. It's the only time we do that formula is resistance in parallel. So we did 1800 x over 1 plus 2485 x over 1. Just gave us 1043.87 ohms. So now I can bring back in my R1 and R6, and they're in series. Now I have three resistances in series. You all know what we do there, right? So we've got 12 volts. What's the total? 116. Okay, it's going to be 1,000.
1318.87.
1318.87 ohms.
Okay, so
The 1043 plugged in where is it?
1043, do you know where that came from?
Yeah, I know where it came from.
Okay, so I've got a 75 ohm up here,
Uh-huh,
and I've got 200 down here.
okay.
So
So
these,
you just added those in?
so it's now a series circuit.
Okay.
We've taken a series parallel circuit and we've converted it into a series circuit.
And,
We have three resistor values in series, which we can convert into one resistor. So we just added them together. And we've got 18.87 ohms. Now we've got a very basic, we know our resistance total, 1887. This orange. 18.87. So there's my resistance total. So now, having a total voltage and a total resistance, what's my total current? 0.009. And what other resistors share that same current? 1 and 6. 1 and 6. So this is my river again. 0.009 is flowing up here. It splits for a while, and it comes back again. We haven't gained, we haven't lost. It's still flowing at 0.009 amps. So what's going to help us next? We have a total current. We know the current here and the current here. Thank you. If we know the voltage drops here and here, we know the voltage drop in the middle. So what's our voltage drop? We've got, if we look at it, just look at our grid, we have two values in R1 and R6. We don't even really have to think about it. We get our volts. So what's R1's voltage? 0.675. And R6's? 1.81. 1.8. So now back to this problem right here. That's volts. I have 0.675 volts here. I have 1.8 volts here. What's my voltage in the middle? 9.525. 9.525?
Yes.
Where are my three voltage drops? If I add those three, they should add up to 12 volts. So now, where can I write that 9.525 volts? Where will that go over here in the grid? R2. And I'll explain why again. I'm going to go ahead and write it first. 9.525 volts. Okay, that's because this middle section right here at 9.25 volts is here. It's from starting here and in here. So right in this middle section is a parallel circuit with 9.525 volts. Up here is the 6.75, down here is the 1.8. So again, I can redraw this if it helps me. 1800 ohms, and I can do it this way. Just do 2485 ohms. Is that the same problem? Is this center section? Do you see that the center section here is the same as that center section? There's my voltage drop between here and here. 1800, this resistor sees the full voltage, these share it. I'm not gonna, I've kept them combined because why? What do I want from that combined value? Current. and with the current. So I have a combined value on this side, 1800. I can figure the current easily here with the voltage and the resistance. And if I use the combined resistance and the voltage drop, I get the current for that path. So what's my current for R2? Right here. I mean, you just look at my grid. I don't even have to really think.
0.005.
0.005. But you notice I didn't even really have to think that far. I now automatically had two values. Now I'm leaving power alone because I can do that. It's just a couple strokes with my calculator. But you notice I had two values. I can quickly get current, and current's something I can use. So now I've got current. These three currents are going to be the same, right? They're series. They're also going to be, I already know what they are, 0.004. Does anyone see that?
No.
0.009. If I have 0.009 up here at the beginning of my river, and over here I have 0.005 amps, what do I have down the right side? 0.004. I just did it because I saw that the total current was 0.009 way up here, and I knew that this path was 0.005, which we just figured out.
So that's always gonna be distributed the same amount to
Whatever passes all these paths will add up to whatever comes in and goes out. It's just the same as if it were a real river. If that river splits, it won't always be equal. You might have a very tiny path and this big raging path. But when you do a cross section, they will add up, no matter how many I have across here. I get 8 or 10 of these. As long as they all came from one source. Adding them all up will tell me how much I started.
Well, I mean, each one of those, 3, 4, and 5 they're gonna be always equal to 0.004, even though, or is it gonna be a different number? I know it's gonna add up to 0.009.
Okay.
But is it gonna be
Here is
0.004 evenly across?
this is 1, 2. This is 3, 4, and 5. Here's 3, 4, and 5. Here's R2. So down this path, I have 0.004, right? Series, what do we say about current in series? It's the same. So if this sees 5,000 gallons per minute and 4,000 gallons per minute, each little campsite is going to see the same amount of flow past their tents. So now I have 0.004, 0.004, 0.004. I have two values. I'm done. I can figure the voltage for each one of those. You'll find that these three combined will add up to the one they're just parallel to. This 1800 sees 9.5 volts. These three combined will be about 9.5 volts.
Because the volts is always constant.
Because the voltage is the same, but since there's three of them in here, you've got a series inside of there now. So each one of these, if you want to do them, what's the voltage for R3? 5 volts. 5 volts, then 3 even. 1.9. 1.9. So 5, 6, 7, 8, 9.9. So 9.9. The only reason they're not identical is rounding. That's the only. Otherwise, if we had followed all the way out to the end, those numbers would have been identical. So we add each. There's the voltage drops: 5, 3, and 1.9. Add up to the drop. Here's our drop again. 9.5 volts goes from here to here, and 9 volt drops from there to there. 7:30.
That's it for that problem?
What's that?
That's it for that problem?
Yeah, that's it.